This is Cambridge Chemistry channel. Today we will discuss part 3 of specimen paper 22. Question number 27. An alkene is reacted with acidified manganate ions. The organic product has relative molecular mass greater than that of the alkene by 34. So what conditions should be used? Cold concentrated manganate ions. We cannot do this. So 34, it is greater than 30 by 34. The molecular mass is greater than that of alkene by 34. 34 means that 2 OH is present. So 2 OHs mean 34. So for this condition cold dilute, because when alkene react with cold dilute manganate ions, so diol is formed. So for example, so this must be correct, like this. If alkene react with MnO4 negative, it must be with cold condition dilute, so it form diol. So addition of 2 OH group increases the molecular mass 34. So it would be correct. Hot concentrated, let's check this option as well. Hot concentrated manganate just cleavage the double bond, break the double bond, and 2 carboxylic acids are formed, and hot dilute as well. Dilute. Okay, so B option is correct. The diagram shows a short length of an addition polymer chain. The polymer has a relative molecular mass of approximately 10,000. So approximately how many monomers units? Approximately how many monomers units are joined together in polymer molecules? So you know that molecular mass of polymer is equal to the monomer. The number of monomers join to form if 2 monomers join to form 2 units, 2 long units are formed. So that's why if this is the monomer, if ethene is a monomer, so and approximately 10,000 monomer, so the number of how many monomers units, how to calculate number of, we can use this formula. Monomer is equal to mR of polymer divided by mR of monomer. So this the monomer could be ethene. So the mR is 10,000 of polymer, and monomer mR is ethene C2H4. The mR is 24 plus 4 is equal to 28. So this could be equal to 10,000 divided by 28 is equal to 357. So this is 357. So approximately how many monomer units? So it means 360, approximately 360 ml. So B option is correct. So next, lactite. Lactite is an intermediate in the manufacture of synthetic fiber. So which compound on heating with an acid catalyst can produce lactite? Which compound on heating with an acid catalyst can produce lactite? Which compound on heating? So this is the intermediate, I think so. This is O, this is double bond O, and this is O, this is double bond O. The molecule can be, this is ester molecule, two esters are formed, so it could be like this: double bond O, and over here must be OH, yes, and over here O, it must be OH. So this is the intermediate, so it means two molecules, 2 moles of this compound, and this process is known as condensation. In the presence of acid catalyst. So which compounds on heating with an acid catalyst can produce lactide? So this is C. 1 2 3 1 2 3 hydroxyethanoic acid. Hydroxyethanoic acid, OH, and hydroxyethanoic 1 2, and over here, so this is 1 2 3 1 2 3. So this is correct or incorrect? 2-hydroxybutanoic acid. 2-hydroxybutanoic acid. So yes, the formula could be 1 2 3 4 2-hydroxybutanoic acid. So 1 2 3 1 2 3 is also incorrect. 2-hydroxypropanoic acid, C. 2-hydroxypropanoic acid, 1 2 3, COOH, 2-hydroxy OH. This is 2-hydroxypropanoic acid, 1 2 3. This could be 1 1 2 3, and this is 1 2 3. So this must be correct. And 3-hydroxy, let's check this formula as well. Propanoic acid, 1 2 3, COOH, 3-propanoic acid, 3-hydroxypropanoic acid, 1 2 3. This is OH. So this is 3-hydroxypropanoic acid. This could be, no, look at this, carboxylic acid. So we can number from carboxylic acid. So this could be, yes, 1 2 and 3. 2-hydroxypropanoic acid, and 3, this is 3-hydroxypropanoic acid, so this is also incorrect. So C option is correct. Diol is in which both hydroxy groups are bonded or to the same carbon atom. Spontaneously eliminate a molecule of water to produce a carbonyl compounds. Same carbon atom, 1,1-dibromo. This is the molecule is 1,1-dibromo, and spontaneously 1,1-dibromo to produce carbonyl compounds. Which compound is hydrolyzed to form a product that gives a positive reaction with 2,4 diols, in which could be, this is OH and OH. So on the same carbon atom we are, and this convert 2,4-dinitrophenyl but not with Fehling solution. So it should be not with Fehling solution, should be ketone, and 2,4-nitrophile carbonyl compounds. Said carbonyl and compound can be ketone. Compound should be ketone. Yes. So this should not be ketone. This is on hydrolysis from aldehyde. So it is incorrect. 1,2-dibromo, 1,2-dibromo, 1,2-dibromo. This is aldehyde as well as ketone. OH. This could be aldehyde and this could be ketone. So it is also incorrect. 1,3-dibromo, 1,3-dibromo, 1 bromo and 3 bromo. 1, 2, 3. So this is also incorrect. 2 aldehydes are formed. 2-diol, OH, 1, 2, 3, OH, 2 aldehydes. So this is also incorrect. Now let's check D. So remove this. Now let's check D. 2,2-dibromo propane, 2,2-dibromo, 1, 2, 3, 2,2-dibromo, 1, 2, 3, 1, 2. So 1, 2, 3 and 2,2-dibromo. Br, B, OH and OH. So same carbon atom, 2 OHs on same carbon atom spontaneously eliminate molecule of water. This could be water to produce carbonyl compounds. So this is D is the correct answer. X and Y are reagents required to convert 1-bromoic propane into butanoic acid in the following reaction. Okay. BrXCN Y. Br must be X must be KCN in ethanol and YCN hydrolysis. This is acid hydrolysis, because if there is if we use base like sodium hydroxide, it should be OH, not OH, it should be ONA. So if it is OH, then it is based hydrolysis, not acid hydrolysis, not base hydrolysis. What are the correct identities of X and Y? HCN not possible. This is simple molecule, not dissociate into hydrogen and cyanide. So this is aqueous. This is incorrect. KCN and ethanol are correct. Sodium hydroxide is incorrect. And KCN in ethanol, HCl is correct. This is correct. So C option is incorrect. C option is correct. HCN again, base hydrolysis is not correct. HCN is not correct. So C is the best option. Q is a compound with the molecular formula C4H10O. Q can be oxidized with acidified potassium dichromate. Q cannot be made by reducing carboxylic acid with lithium aluminum hydrate, tetrahydride, lithium aluminum tetrahydride. This could be, Q cannot be made by reducing carboxylic acid with lithium aluminum tetrahydride. Okay. So lithium aluminum hydride cannot made by Q cannot made by reducing a carboxylic acid with lithium aluminum tetrahydride. Can reduce carboxylic acid. So this is OH, and dichromate when react CH3, C double bond O, CH2 and CH3. Q is compound molecular, so Q can be oxidized. Yes, Q can be oxidized to form ketone, and this ketone cannot be made by reducing a carboxylic acid with lithium tetraaluminum hydride. So this must be correct. CH3, CH2, CH2, this form carboxylic acid, CO2H, and this can be made by reducing lithium aluminum. This cannot, because this is tertiary alcohol, so can't oxidized. CH3, CH2O, this is also a primary alcohol, form carboxylic acid and can reduce by using LiAlH4. So A option is correct. 33. A sample of 2.30 gram of ethanol is mixed with an excess of aqueous acidified potassium dichromate. The reaction mixture is then boiled under a flux for 1 hour. The required organic product is then collected by distillation. The yield of product is 60%. So first calculate the mass of carboxylic acid, because ethanol C2H5OH oxidized to form ethanoic acid C3COOH. This is 2.30 gram, and this is yield of product is mass. Can we find out? We know the MR is 46. 2 point, if we know this is 1-to-1 ratio, so 2.30 divided by 46, x over the MR of is 60, x over 60. So by using cross multiply, we get the mass of the carboxylic acid, ethanoic acid. So the mass is x is equal to 2.3 into 60 divided by 46. This is equal to, let's calculate, 2.3 into 60, 2.3 into 60 divided by 46 is equal to 3. So this is 3 gram. So we know that the yield of product is 60%. So if 100 gram contains 60% yield, so what would be the yield of ethanoic acid in 3 grams? So 60 into 3 divided by 100 is equal to 6 and 3 6 were 18, and this is equal to 1.8. So 1.80 gram is correct option. So come to the, is it clear? So this is the correct option is 1.80 gram. So now next question, compound R gives a positive test with alkaline aqueous potassium iodine, aqueous iodine. Compounds R does not display stereoisomerism, mean nor geometric and neither geometric nor optical. So R does not display. So alkaline aqueous iodine, if CH3CO, CH3C double bond O can react with the alkaline aqueous iodine to form CHI3 yellow PPTs. So does not show geometric or optical isomers, so it must be A. CH3 CH2 CHO CHO. So B, let's check B. 1 2 3 4 1 2 3 CHO OH does not react with alkaline, so iodine, because not present CH3 C double bond O. So this must be incorrect. CH3CO, this C. So look at C, why it is not correct. 1 2 3 4 1 2 3 4 CH3 C double bond O shows reaction with NaOH iodine, but also CH3CHO OH shows, and also stereoisomerism, rather not shows optical isomer, because this is 4 groups are present, so it also incorrect. And D is, look at D, CH3 CH3 OH 1 2 3 and CHO. This is not showing this reaction, and carbon and nor, so the compound must be a positive test with alkaline aqueous iodine, so this is also incorrect. So A option is correct. So this is citral. Citral is found in lemongrass oil. It can react to give compound W. An excess of H2 and I all could be saturated. Double bond break, the compound could be, is also reduced to form OH and complete saturated, and hot concentrated acidified manganate under reflux, so the W could be COOH. So CHO, so B option is correct option. P and Q are alkenes. They are geometric isomers. Of which statement is P and Q give different products? Not giving different if they are isomers of each other, same products with hot concentrated acidified potassium manganate. P and Q have different empirical formula. No, P and Q have same formula, so it is incorrect. It is also incorrect. P and Q have different functional group. No, P and Q have same function because both are geometric isomers of each other, so same functional group, so it is, so P and Q have different, yes, different skeletal formula could be. The following statements are about the reaction of NaOH with the 3 chloroalkanes shown. Okay, this is secondary, this is primary haloalkane, halo, and this is tertiary haloalkane. Okay, which statement is correct? Say 3. This is primary react with sodium hydroxide by an SN2. This is primary haloalkane exhibit SN2 mechanism. This is correct. The tertiary chloroalkane react more quickly. No, not more quickly than the other, because the carbon atom bonded to the chlorine atom is more positive in this. No, this is first step SN1 reaction, and SN1 reaction tertiary, and step 1 is slow step. So this is incorrect. See, the chlorine atoms in the 3 chloroalkanes are attacked by OH ions. Cl atoms in the 3 chloroalkane. No, not Cl atom. This is carbocation in the 3 chloroalkanes are attached by OH negative. The molecular, this is incorrect. The molecular formula of the major product is C4H8 for each reaction. The molecular formula of the major and minor both should be C4. This is also incorrect. For which mixture is the observation described correctly? Pentanol plus failing reagent. Blue solution changes to orange red precipitate. Yes, it is correct. Pentanol hot potassium manganate dichromate. Green solution changes to orange to green. So this is incorrect. C pentane 2-on plus bomb tolerant reagent. Colorless solution changes to silver. Pentane 2-on does not show positive test with the warm tolerant reagent. So this is also incorrect. C6H14 plus, this is hexane plus acidified potassium manganate, purple solution changes. This is does not show positive test, not react with C6H14, does not react with acidified potassium manganate. So this is also incorrect. So A option is correct. Which statement is correct? C3H7 COH can be used to form propanoate in a single reaction. Not propyl propanoate, this could be butanoate. So this is incorrect. The empirical formula of C3H7COH is same as its molecular formula. Empirical formula of C3H7 is the same as, no, this is C4H8O2. So 2 1s are 2 4s are 8, 2 2s are 4. So the empirical formula would be C2H4O. So this is also incorrect. The empirical formula of C3H7COH is the same as its molecular formula. Each of C3H7OH and C3H7COH reacts separately with NaBH4. C3H7OH C3H7COH cannot reduced by NaBH4. It can reduced by using lithium aluminium hydride. So this is also incorrect. Each of C3H7OH and C3H7COH, propanol and butanoic acid react separately with sodium. Yes, both can react like this. C3H7OH plus sodium metal to form C3H7 sodium to form ONA plus H2 gas. Or similarly C3H7COOH okay, C3H7COH plus sodium to form also C3H7 CO2 Na plus H2. 8, 7 or 1. So this option is correct option. Compound X consists of carbon, hydrogen and oxygen only. It has only one functional group. So this is the peak of C double bond O, as this is 15 to 1700 wave number. At 15 to 1700 C double bond O group is present. Carbonyl carboxyl carbonyl 1500 to 1700 aromatic C double bond O. So this could be C double bond O. Now this is the broad peak. Broad peak is the OH peak and this is OH of around about 3000 3300. Carboxyl 2500 to 3000. We start from here 2500 to 3000. This is carboxyl. So this what can be deduced about X? X is an aldehyde and ketones. X is an alcohol, not only alcohol, along with C double bond O. So X is carboxylic acid. Only one group is present. So this could be C double bond O OH. So C option is correct. So this is all about the 9701 specimen paper 1. Hope you like it. If you like this video, please subscribe this channel to support me, and do comment, and if you have any query, please ask me in the comment box. Okay, Allah Hafiz.